Greetings everyone, welcome to today's video. Welcome to another day. I hope you're all well. In today's video, we'll be doing the range and standard deviation, which will be the third part in statistics made simple. And therefore, without much further ado, let's jump into the video. From our previous videos and the first part and the second part specifically, we defined what the set, mean, mode, median, and range were. We also defined what the range is in this particular video. We also talked about what affects the mean, the median, and the mode. We also did other properties of evenly spaced sets and symmetrical sets with respect to the mean and the median. And so if you're not familiar with either of these, please go to the description box below, look for the particular video that you'd like to watch, click to it, watch, like, share, and subscribe for more content. And so let's define what standard deviation and range are. Let's do standard deviation. Standard deviation is the deviation from the mean, and range is the maximum value minus the minimum value. I believe this is self-explanatory. Just take the biggest value in the set and the smallest value in the set, then do the difference. All right. For the standard deviation, it's the deviation from the mean. It's actually a long process where you do actually calculate the standard deviation. And for this particular video, I'll show you how to calculate the standard deviation. The GMAT will not ask you to calculate the standard deviation, but you need to know how the standard deviation is calculated so that you can obtain that reference whenever you're doing a standard deviation, and how different aspects in math and GMAT Quant specifically affects the standard deviation. And so for the calculation of standard deviation, I'll take three consecutive integers that say 1, 2, and 3. Let's take a set with 1, 2, and 3. And the total for the first step, find the mean of the list. The mean is definitely 2. So let's draw like a table. The mean, let's do x bar equals to 2. Then subtract the mean from every value of the set to produce a second list of elements. Now we have the first list, subtract the mean from each value. 1 minus 2, that's -1. 2 minus 2, that's 0. And 3 minus 2, that's 1. That's the second list. And then square every deviation to produce a third list. Now we need to find another third list, a list of squared deviations. We need to square this second list, so we can have -1 squared, that's 1, 0 squared, that's 0, and 1 squared, that's 1. All right, this is the first list, this is the second list, and this is the third list. All right, after finding the third list of squared deviations, what do? We find the average of the third list, that's the variance. And how do we find the average? That's 1 plus 0 plus 1 divided by 3. This should be 2 over 3. This is what we call the variance. Right? Now check the square root of the variance to get the standard deviation. Now the square root of the variance is the standard deviation. The SD, I'll use the SD to mean the standard deviation. And how do we do that? We do the square root of 2 over 3. And that should be the standard deviation. You can do using the calculator, but the GMAT will not expect you to find the square root of 2 over 3. And that's how you calculate the standard deviation. With that being said, let's see some of the properties of the standard deviation. And these are properties that most students fail to master or fail to know. And therefore, let's mention these properties of standard deviation, where the first one being the standard deviation can be only 0 or a positive value, and not a positive integer, but a positive value. And it can be only 0 when or if the elements in a set are identical. A set with 1, 1, 1, that's when the standard deviation will be 0. All right? Or a set with 80, for example, 80, 80, with the number of 80s in the set, as many as you like, but the elements in the set are identical, then the standard deviation equals to 0. Otherwise, the standard deviation can be positive. If the elements of the set are not identical, then the standard deviation will be positive. All right. And the third property of the standard deviation is it can increase or decrease if an element is added or removed from a set. We'll see this in the next slide. And please note these three properties of the standard deviation. They're frequently tested when a standard deviation comes up in the GMAT, and standard deviation is usually tested in high-level questions, mostly in high-level questions, because many students can't understand how these properties comes to play, different aspects, what affects the standard deviation, as well as the calculation of the standard deviation with respect to these calculations. All right. Here are some few points that you need to know. If all the numbers on a list are exactly the same distance from the mean, the standard distance is the standard deviation. Let's take this set 2, 2, 2, 8, 8, 8, where the mean is 5. You can try to do that. This is 2 plus 8, that's 10. 2 plus 8, that's 10. 2 plus 8, that's 10. 10 times 3, that's 30. 30 divided by 6 elements, and the mean should be 5, right? And the standard deviation is 3. How is the standard deviation 3? If you have 5, 8, 8, 8, then 2, 2, 2. Note that the distance of 2 from 5, that's 3. Same applies to all 2's in the list. And the distance of 5 or 8 from 5, that's 3. Again, same applies to all elements in the list. And therefore, this distance 3 from every element in the list is what we take as the standard deviation. As quick as that, you don't have to do the calculation. And by doing the calculation, you'll see this. This is a number sense that some student or some test taker did these standard deviation questions, a lot of practice, and this is what they came up with. All right. A set with the most numbers clustered towards the extremes will have a higher standard deviation than a list with most values equal to or close to the mean, right? The more the distance of deviation from the mean, think of this as the calculation of the standard deviation. The more the distance of the values from the mean, the greater the deviations, the bigger the negative value, the bigger the positive value squared, which produces a bigger value when square rooted will be even bigger compared to those closer to the mean. All right. Here are the effects of manipulating elements on the standard deviation. And these are very crucial points. Effect of increasing and or decreasing such elements on the standard deviation. Given that you decrease or increase elements of a set by a constant percentage, then the standard deviation should increase or decrease by the same percentage. Given that you have values, let's take a value, 100, for example, and 200, that's the set, and say the average, that's 150. Therefore, the distance of all elements from that, that's 50, and this 150, this 50. Therefore, the standard deviation should be 50, right? If we were to take, or let's say decrease in this time, decrease these elements by 80%, not decrease by 20%, that can have 80% of the elements, 100 and 200, that should be 80, and 80% of 200, that's 10%, that should be 20. 20 times 8, that's 160. And this new standard deviation will also decrease by 80%. We don't have to calculate that. Let's do 80% of 50, that should be 40. And can you prove that? Let's have 80 plus 160, that's 240. Divide by 2, that's 120. That's the mean. What's the distance of 120 from 160? This is 40, and this is also 40. As you can see, without even calculating, a decrease or increase of elements by a set percentage or constant percentage, then it will also affect the standard deviation by the same percentage. If you multiply then every number on a list by a positive value k, the standard deviation also gets multiplied by that value k. Same applies to the mean. And for this particular example, I'll like to use the 2, 2. Let's use 4 values, 2, 2, 2, 2, 2, and 8, 8. These are set. All right, with that being known, let's multiply these. We know that the mean is 5, therefore the distance is 3, and the standard deviation should be 3. Let's multiply these sets by 2, for example, and have a new list with 4, 4, 16, 16. And what's the average? 16 plus 4, that's 20. 4 plus 16, that's 20. This is 40. 40 divided by 4, that should be 10. The distance of 10 from these 4s and 6 is 6, and is from that that the standard deviation is 6. Note that this set was multiplied by 2, and therefore the standard deviation is multiplied by 2 to have a new standard deviation of 6. And that's how manipulating elements on the set affects the standard deviation. All right, and then what happens if you increase all elements of a set by a constant value? And what do I mean by this? Let me clear this slide. We have, say, 2, 2, 8, 8. Let's add 10 to each value so that we can have 12, 12, 18, 18. Then the previous standard deviation was they had a 5 of mean, so we have the standard deviation as 3 for this list here. What's the standard deviation of this one? Let's have 12 plus 18, that's 10, 20, 30. That's 20 plus 10, that's 30. 30 plus 30, that's 60. 60 divided by 4, that's 15. We have the mean as 15. What's the difference of 18 from 15? That's 3. Same applies to 18. Same applies to 12, 3. Same applies to other 12, 3. Right? With that being said, the standard deviation equals to 3. The standard deviation actually doesn't change. What does it not change? This reason has to do with the bolded statement that I had placed in the slide. The standard deviation has only to do with the spacing between numbers, not the place they hold on the number line. Thus, as the spacing between the number lines stays the same, the standard deviation always stays the same. As you can see, the spacing never changes. Same threes from the previous set, and therefore the standard deviation remains the same. Very crucial point.
You're watching Success with Bob Mwiti Show, presented to you by Upstake America. Upstake America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstakeamerica.com. Upstake America, we wake you up to the unlimited potential.
All right, and then let's look on what happens when you add new elements to a set and how it affects the standard deviation. If a new element, y is added to a set that's xi, and the standard deviation of the new set, this one, this is the old set plus the value, new element is the new standard deviation, then these are the 4 other crucial points that you need to know. Let's draw a representation of that. Let's have the mean here. You know that the standard deviation, original standard deviation is here. That's the deviation from the mean. Let's say the distance was 3 and 3 as the sets that we've used. And then we have values, of course, distributed all around, right? Values of a set. All these dashes are values of a set. Now let's explain how these 4 come about. If let's use the distance of the new element from the mean is greater than the standard deviation, means that a point from 1 is added greater than the standard deviation, then the new standard deviation is pulled towards those points, and the new standard deviation will be greater than the old standard deviation. The distance of the new element is bigger than the old standard deviation, which was, then the new standard deviation will be pulled outwards towards the new element, and therefore the new standard deviation will be greater than the older standard deviation. All right. If the new element distance from the mean is equal to the standard deviation, means from point 2, the new element now is added right where the standard deviation is, then the new standard deviation will remain the same to the older standard deviation, right? And for the third one, the distance of the new element from the mean is less than the standard deviation, is a point from the third statement, is less than, then this standard deviation is pulled inwards or closer to the mean, and therefore the newer standard deviation will be less than the older standard deviation. All right. And what happens when you put the new element right where the mean is? Right? When you put the new element where the mean is, that's where you minimize the new standard deviation to its lowest. So you can add as many values to the mean so that you can pull the standard deviation closer to the mean to minimize and make the standard deviation at its lowest. You can understand this from the calculation, and I've already drawn a visualization of what I mean from the effect of adding a new element to the set's standard deviation. And we can express this in terms the linkage between the standard deviation, the mean, the range. We're using the bell curve, also known as the normal distribution. The normal distribution usually happens when you relate activities or characteristics to human beings, the production of instruments, the characteristics of human beings, being tall, being short, the weight of human beings, and so on and so forth. And this is represented by a bell curve, which I'll draw, usually depicted in that manner. And it's symmetrical at the center, where you have the mean, and the mean equals to the median, equals to the mode, right? We have one standard deviation to the right and one standard deviation to the left. We have the mean. Let m equals to the mean, and this symbol to the standard deviation. So this is the mean minus the standard deviation, and this is the mean plus the standard deviation. The distance between the mean and the one standard deviation, usually 34% to the right-hand side and 34% to the left-hand side. And so let's do some questions now. Please pause the video, give it a try, then I'll jump in and we'll do this question together. Is the standard deviation of the numbers x, y, and z equal to the standard deviation of 10, 15, and 20? Let's find the standard deviation of 10, 15, and 20. These are consecutive multiples of 5, therefore the mean equals to the median. Also note this is a yes, no, DS question, right? We need a consistent yes or consistent no to prove sufficiency. Distance of the values from the mean equals, this is 5, and this is 5, and this is 0. So we'll have some values there. That's 5 squared plus 5 squared plus 0. That's 25 plus 25, 50 divided by 3. We'll have a square root. And therefore, we need the values of x, y, and z being multiples of 5, given we have, say, 20, 25, and 30, right? With certain number added to each and every value of the elements in this set, so that can have the same standard deviation of actually x, y, and z being 10, 15, and 20 as well. So let's find out this. Statement 1, z equals to 10. This means that z equals to x plus 10, all right? With that being said, z being x plus 10, then you'll have x, then you'll have value x plus 10. That's z. What about the value of y? The value of y means that we don't have the value of y, right? If y equals to x plus 5, then the standard deviation of that will be equal to this set here. But if y was any other value, then the standard deviation will not equal this set here. And that will have a yes and no, not consistent, therefore not sufficient. If not sufficient, then A and D are out. The second statement with z minus y equals to 5. This means z equals to y plus 5, right? Now we have y and y plus 5, which is z in this case. What about the value of x? If x equals to, say, another value, y plus 10, then we'll have y plus 5, y plus 10, same standard deviation with this set. Therefore, yes, it will be. But if x was any other value, then it wouldn't be the same standard deviation as the set 10, 15, and 20. With that being said, this is not sufficient as well, and therefore B is out. Let's combine 1 and 2. Combining 1 and 2, we know that z equals to x plus 10 and z equals to y plus 5, right? If that's being said, y plus 5 equals to x plus 10, and this means the difference between y minus x equals to 10 minus 5. As you can see, this is a sequence of multiples of 5, or if not the multiples of 5, we have a value with the difference between the distance between the values being 5, 0, and 5 as this set here, and therefore this is sufficient since the set will always have the same standard deviation as 10, 15, and 20, and therefore is out. C should be answer for this question. Let's try this other question. Please pause the video, give it a try, then I'll jump in. The numbers in set P denote the distance of certain positive integers from -1. P denote values from -1 and on the number line, and the numbers in set Q, in Q, the distance of the same integers values from 1 on the number line. Which of the following statements is true about the standard deviation of the sets of P and Q, right? Let's take some 3 integers and find the distance of the values from -1. Let's take 2, 3, and 4. The distance of 2, 3, and 4 from -1, this is 3, this is 4, and this is 5. The same distance from of the values are from 1, that should be 1, 2, and 3, right? As you can see, 1, 2, and 3, if you were to add 2, we'll have 3 plus 2. If you were to add 2 here, we'll have 4, right? And if we were to add 2 to 3, you have 5. So we'll be adding, this is the same set. If you have 1, 2, and 3, add 2 to all the values in this set, we'll have 3, 4, and 5. And from our properties of the standard deviation, you know that adding a value to each number in the set, but still maintaining the distance between the values, the same distance as 1, 1, and 1, 1, then the standard deviation remains the same, and therefore the standard deviation of P equals to the standard deviation of Q, and that's therefore the answer is A. Sorry about that. Let's give this other question a try. Please pause the video, give it a try, then I'll jump in. A certain characteristic in a large population has a distribution that is symmetric about the mean M. Definitely the thing that pops up in your head is the normal distribution. If 68% of the distribution lies between one standard deviation, D, of the mean, in this case, standard deviation equals to D. Remember that we did that. You know that that's 34%. We have the mean here, and then one standard deviation to the right, one standard deviation to the left. This is 68%. Divide that together since it's symmetric, right? Therefore, this is 34%, 34%, right? And then what percent of the distribution is less than one standard deviation of to the mean, that's or to the right, values less than that, right? We don't need this. We need our values from here all the way downwards, all this part, right? But note that this is symmetric, and therefore, if you divide this mean and have the left-hand side, that should be 50%, and to the right hand, this is 50%. The left-hand side equals to the right-hand side, since 34% equals 34% as well. And since we know that 50% is what is less than mean, then we know that the value that we also need is the distance between the mean and one standard deviation to the right. That's 34%. Then we'll add whatever we had less than the mean, that's 50%, plus what we want also, that's 34%, and have 84%. That should be our answer, D. As you can see, these are high-level questions, but with this knowledge that I've shared on the first part of the video, the questions becomes easier and easier. And we need to know and practice a lot of standard deviation questions so that you can get this number sense and flow when doing the GMAT questions. Here were some of the examples and concepts on standard deviation at the range. However, I'll be doing more practice for the next video in this series. So please like, subscribe, stay connected, always share this content to your fellow students or test takers, and put it in the comment section below what videos would like us to tackle in the future. Thank you for coming today. Thank you for watching the video. Bye-bye. Till next time.